Welcome to my PHUSE-US 21 speech, the encoding dilemma. I know this is not really a new topic, as it is a recurrent aspect discussed at conferences such as the SAS Global Forum. However, I thought it was a good idea to bring again to the attention of the statistical programming community this technical topic, as it could be a source of errors if not correctly understood, especially these days where data are coming and share from various sources with several data vendors involved. This is the agenda with a bit of encoding theory. Then I will provide a few tips on how to handle transcoding from one encoding system to another. And I will finish with a sort of bonus topic, giving some hints on regulatory agency requirements with regards to encoding. Very often, SAS logs are plenty of, let me say, weird messages, and often SAS programmers ignore these messages unless an error prevents their SAS session to execute correctly their program and without errors. I'm sure most of you have come across with at least one of these messages. There are notes and warnings telling you that SAS has done some action for you. While in the first case here, your local SAS session was able to correctly transcode characters coming from a different SAS encoding configuration, in the second case, not all characters were correctly transformed and interpreted by SAS, and even worse is in the last example, some characters make SAS fail. Before we try to troubleshoot and resolve this transcoding issue, it is helpful to understand why those issues occur. Let us start with some encoding background first. In computers, characters data are stored as a series of bytes, which is made of binary digit called bits. In this context, a character is a generic wording to say any kind of character symbol that could be represented by a computer system, such as letters, digits or numbers, punctuation, and any other special symbol and characters. As such, in computers, each character to be correctly represented is assigned a number. For example, with 1 byte, so 8 bits, we can represent 256 characters, each one identified by a number ranging from 0 to 255. This way, computers interpret and represent the characters within the data by assigning an integer number. So this way of assigning an integer number is called encoding. And each encoding system has its own way of assigning a number to each character. So the encoding method of a specific encoding system is defined by a set of rules where each number is assigned a character. But because our computing environment are not perfectly standardized, there are type of encoding in use, and each encoding has its own character and encoding methods. For example, in SAS, with the W Latin 1 encoding, the letter A uppercase is represented by the number 65, which is then translated to a sequence of 8 bits, so 1 byte. With this encoding system, we can represent most of these Western European languages, such as English. Essentially, we can represent all ASCII characters, including control characters and extended ASCII characters. Instead, other languages such as Cyrillic or most of the Asian languages can be not fully represented or not represented at all. They cannot represent at all their alphabets because they use a totally separate set of symbols not available in the ASCII standard. Because of that, because some encodings require to represent different and more characters sometimes, the storage size of each encoding might differ. While with W Latin 1 byte is enough, so it is said it is a single byte character set, for other encoding 1 byte is not enough. For example, the Shift JS, the encoding system that defines encoding rules for Japanese characters, and Big 5 for Chinese characters, they both require 2 bytes to fully and correctly represent all characters in their respective character sets. The UTF-8 encoding defined by the Unicode standard, it is an attempt to overcome the different national languages requirement. With this encoding system, in fact, more than 120,000 characters can be represented. So, and some might still need 1 byte, other 2, with up to a maximum of 4 bytes. For this reason, this encoding is defined as a multiple byte character set. One also important thing to mention is that some characters that in the W Latin 1 require by definition 1 byte, in UTF-8 the same characters might require 2 characters, 2 bytes. Let us go back to the issue we saw at the beginning, and let's start to see how encoding and transcoding is handled in SAS. The encoding defined by your SAS working environment determines the default encoding for your SAS session. For example, assume you are creating a CDISC STTN dataset in your SAS session. All the STTN dataset created will be saved using the encoding defined by your SAS environment. So if your configuration used by default W Latin 1, then by default any SAS dataset you create in your session, either permanent or temporary, will be created using the W Latin 1 encoding. For this reason, it is important, critical to be aware of what encoding is by default used by your SAS configuration, so that you can also inform and prevent your client or your regulatory agency. You can check this in SAS in at least 2 ways, and one of these is by querying the encoding option using the proc option. For example, the default SAS configuration at CITEL is W Latin 1 encoding. We discussed so far about encoding, but let's also clarify a couple of topics related to transcoding. Transcoding is the process of converting from one computer encoding to another. Given the fact a character could have different numeric representation in 2 different encoding, if you are receiving dataset generated in a SAS environment with a different encoding, the first thing SAS will try to do is to make the needed transformation or transcoding, so that each character is correctly represented and converted in the encoding used by your SAS configuration. SAS does automatically transcoding for you by invoking the cross-environment data access engine. We also saw mentioned in the SAS log earlier. We saw before how to check the encoding used by our SAS configuration, but let's see also how to check the encoding used in the SAS dataset we receive. Again, SAS supply several options, and one is the @C function that again can be used with the %sysfunc macro. Here I just create a simple macro as I want to make a number of examples in my next slide. Of note, the other way of checking the encoding is by using the proc contents, which will also give you more details. Also, I will make use of 4 libraries, each one containing SAS datasets created with different encoding. And as I said before, I cited by default our SAS is using the W Latin 1 encoding. I can now use the macro to test the encoding on dataset created with different encoding. And let's have a look at the log after running the macros. The first dataset query is a dataset created using a UTF-8 encoding that is different than my local encoding, and same for the second dataset created with a Shift.js Japanese encoding. For both datasets, SAS is alerting us the SAS dataset were generated using a different encoding, while for the last example, because the dataset was created with the same encoding, no notes are written in the log. I mentioned earlier that when a dataset is generated using a different encoding, SAS tries to make the transformation for you. However, there are situations where some characters can be not represented into your SAS encoding session, and as such, the character might be lost. For example, despite our transcoding seemed successful when previously we queried the Japanese dataset, If you try now to open the same dataset, we will see that for one variable in particular, some characters were not correctly translated. And despite the cross-environment data access tried to transcode some characters in the Japanese adverse events, the texts were lost. In such a situation, the only way of correctly reading the dataset content is to change it is by changing the default encoding of your SAS configuration in your SAS out exec. So let's assume we are not aware of the encoding used. We can try with the universal UTF-8 encoding. So what before was partially read when the dataset was opened in SAS W Latin 1 encoding session, it is now correctly read in UTF-8 encoding SAS session. Of course, if you can read the Japanese. With the earlier example, we saw that changing the encoding of our SAS session to match the source encoding could solve the issue. But there are other instances where this is not enough. Let's now take the example of LAV dataset originally created with the W Latin 1 session. When this is transcoded into UTF-8, despite the SAS cross-environment data access, one character in particular was not correctly transcoded. I earlier mentioned that the same character in one encoding system might require 1 byte, while when transcoding into another encoding system, the same could require 2 or more bytes. If you look, for example, at the 256 ASCII characters, we can see that the standard ASCII characters require 1 byte in UTF-8, and same in W Latin 1, while the extended ASCII characters in UTF-8 require 2 bytes as opposite to W Latin 1, which require 1 byte. So the micro symbol is on the list of characters that in UTF-8 requires 2 bytes instead of 1. And if we look at the numeric representation in the two encoding systems, we can see they are 2 different characters. This difference is also reflected in the SAS length, where the macro symbol is of length 1 in the W Latin 1, while the same is of length 2 in UTF-8. So thus, this explains the wrong transcoding. Yes, config, that is the reason. One way of fixing this length issue is to use the CVP option in the libname statement to see the effect to see this in effect, because the CVP option when used makes the SAS library read-only. We need to create a UTF transcoded dataset in a separate SAS library or in the work library. And what will be the effect of the CVP option? Well, first of all, the macro symbol is now correctly transcoded and interpreted in the newly created dataset. But to make this possible, SAS with the CVP option had to increase the length of the unit variable from 6 to 9 bytes, from 6 to 9 length, to correctly represent the micro symbol in the new UTF-8 encoding. Let's now consider the same example, but by assuming the dataset we received has been created in a UTF-8 encoding environment, and now we want to use the dataset in a W Latin 1 encoding environment. If we do set the UTF-8 dataset, we can see again the macro symbol was correctly transcoded and interpreted in the W Latin 1 environment. If we look back at the early Japanese encoded dataset, if we stay in a W Latin encoded environment, we can also notice that if we try to use that dataset, the SAS dataset ends with an error. Many SAS programmers solve this issue by using the encoding equal any option, which essentially tells SAS to not use the SAS cross-environment data access and to ignore the current SAS session encoding. So the encoding heading any option might seem the approach with the best pros and cons balance, as it removes the risk of having errors in the SAS program. But actually, it has to be used carefully, because by ignoring the local encoding, SAS anyhow try to make an interpretation the value as something. So if we try to read in a W Latin 1 encoding SAS session the following lab dataset originated in a UTF-8 encoding SAS session, SAS will not transcode characters that have a different representation. And therefore, again, the macro symbol will be not correctly interpreted. In such case, we may need to take care of the transcoding, somehow manually handle the transcoding of characters having a different representation. For example, by using the kcvt function as per the example in this slide. One last recommendation I want to give is that it also makes sense to permanently convert dataset generated in other encoding to your local encoding before you use those datasets. This will save some SAS resources and execution time. In fact, if you have a look at the log when the cross-environmental data access enter into action, it alerts you it will take some additional resources. The conversion can be done by simply running a proc copy where all datasets of the source library are copied to the new library using the local session encoding. This can save later some CPU time every time the transcoded dataset are used as shown in this example in the slide. I want now to quickly touch the topic of encoding and data submission, and then more in general the requirements for special characters when datasets are submitted to the health authorities such as the FDA. If we take, for example, the FDA Study Data Technical Formats Guide, the agency defines some rules with regard to characters to be used when naming and labeling dataset and variable, but also dataset contents where they recommend restricting the use of standard AXI printable values below 128. So essentially, all characters requiring 1 byte regardless of the encoding used, as we probably previously discussed. The FDA also alerts you on the possible transcoding issue when working with the UTF-8 encoding, and they also explicitly ask you to avoid the use of specific range of characters from the AXI extended set. Regarding the first requirement of avoiding non-printable characters or AXI control characters, one uncomplicated way to fix is the use of compress function, using the compress function modifier to remove all non-printable characters, or to keep all printable characters. For the second requirement, the recommendation is to carefully assess where these characters have been used and find a replacement strategy. For this, I do recommend reading this good paper from past FUSE. For other agencies such as the Japanese PMDA or more recently the Chinese NMPA, the tricky part is on the requirement of providing some items in data submission packages in either Chinese or Japanese. For example, the IA verbatim in the dataset, or even more, the define a reviewer guide in Chinese for the NMPA submission. The translation of some items from English to Chinese in your dataset might expose you to some side effect, as demonstrated by Joseph Hartz in his poster, with this simple example with the CMTRT and the code label. I'll let you have a look at the Joseph poster at the address I posted. Reaching the end of my presentation with a quick summary and some final recommendation. First, make sure to verify the encoding used by the dataset you receive. You should be now aware of some of the implication of moving dataset between different environments using different encoding. And last, verify that the contents of your dataset satisfy the regulatory agency requirements with regards of use of special character. And last, stay tuned and you can get more tips in the paper we will publish after the conference. I'll leave you with a number of good references I also use to study and prepare this topic. And if you have any questions, do not hesitate to contact me.